Good morning to one and all. Once again, I welcome you all for the session 3 that I am going to discuss today. So that will be on energy principles. So in the energy principle, the main criteria is strain energy. So we all knows that there is a stress strain curve for a given material. But what is meant by strain energy? If you see the energy stored within the recoverable part of stress strain curve. So note, it is the area under stress strain curve, nothing but a strain energy actually. But the area above the stress strain curve is called complementary energy, that is U star. For a linear elastic system, U equals to U star actually. So U is the actually the stress strain curve up to elastic limit. Then there will be a one parallel line. Then from that line, you can whatever that area comes, that you have to take it into consideration as a strain energy actually. Then loads can be divided into gradually applied loads, suddenly applied loads, impact loads. When you see the gradually applied loads, there is no time will be 0, and the load will be 0. Two cases, delta will be 0, and for suppose if time changes delta t, then p will become p and delta will become delta. Then suddenly applied loads, there is no t at all, t will be 0, then p become p and delta will become g. For suppose if you vary the time, then p will become p and delta will become delta. Then impact loads, we don't have any kind of this kind of combinations actually. Then you see when you have a gradual applied load, P versus delta diagram if you draw, then there is a gradually it is going, that triangle portion we can consider as a your work done actually. The area under load deformation curve is nothing but a work done or strain energy, load deformation curve. So in the suddenly applied load, directly it will not start from 0, it will start from some magnitude, that is suddenly applied. Then there will be a combination of rectangle value or square kind of diagram you will behavior you will have. Then the strain energy due to gradually applied load, that is nothing but a half into P into delta. Then that strain energy equals to half into P into the delta is nothing but a PL by AE. So therefore you will get the P square L by 2 AE actually. So I think with that that can be completed. Then I would like to open the another document. It is continuation of that. Then U equals to P square L by 2 AE equals to that can be divided into taken out 1 by 2 A into P by A into P by A into AL. Therefore 1 by A delta into sigma into volume, then sigma square into volume by EA. Therefore half into sigma by E into volume. Then U equals to half into stress into strain into volume. U equals to sigma E by 2 into volume equals to Young's modulus into epsilon into volume divided by 2. Then it is becoming E equals to sigma by epsilon x strain actually. Therefore U equals to E into the Young's modulus into strain square into volume by 2. Therefore strain energy due to suddenly applied load U equal to P into D, B into delta, whereas strain energy due to gradually applied load U equals to P square L by 2 AE. The stress member which have axial forces as the design forces shall use the above formula, where P is the axial force in any member, L is the length of the member, AE is the axial rigidity. Then if you see one given truss member or frame member, there here FAB equals to 0, then delta U equals to 0, that means strain energy will be 0. Then FCA equals to W into root 2, then U equals to P square L by 2 AE, and then you can interpret the all values. Then finally you will be getting UAC equals to root 2 W square L by AE. So that is all about the things, two documents. Then let me open to the another document, that is talking about one another example, having two ropes connected to one load, that is W, having the angle of 45 degrees from the horizontal AE, then this is 2AE. That means axial rigidity is being given for the BC rope, that is 2AE, 2 times AE, whereas for AB AC it is being given only AE. Then you can apply the regular procedure, delta V equals to, that means all vertical force equals to 0 at C. Then FCA sin 45 degrees plus FCB sin 45 degrees equals to W, whereas summation of H equals to 0 at C, that means all horizontal forces are equals to 0 at C. Then you will get FCA equals to FCB actually. Then from there FCA equals to FCB equals to delta by 2 sin 45 equals to W root 2. So this is all about calculation of that forces. FCA equals to FBC equals to root W root 2. Then UAC equals to L by 2AE equals to W by root 2 square into root 2 L by 2AE. Then finally we will be getting W square L by 2 root 2 AE. UBC equals to W by root 2 square into root 2 L by 2 into 2 AE equals to W square L by 4 root 2 AE. Then U equals to UAC plus UBC equals to 3W square L by 4 root 2 AE. Deflection of statically determined stress joints. Castigliono's theorem 1 can be used to calculate the deflection of stress joints statement. In elastic structures, the partial derivative of strain energy with respect to the load at any point gives the deflection or deformation in the same direction. So dou U by dou W equals to dou V, whereas dou U by dou W equals to delta H, and dou U by dou M equals to theta. So that is one understanding. Then there is a numerical given here using the unit load method. See this unit load method, by applying the unit load method, you can see this numerical delta Vc equals to dou U by dou W, where U equals to total strain energy of truss, and delta Vc equals to vertical deflection at C. Load W is acting at the point where deflection is required. Unit load method, it is the extension of Castigliono's theorem to calculate displacements in various structures. In case of trusses, delta equals to summation of PKL by AE, where P equals to force in a member due to the given external load system, and K force in a member by applying unit load in the direction at the point where deflection is desired. After removing the given external loads, then L is length of the concerned member, A is axial rigidity of the member actually. Then calculate horizontal and vertical deflection at C by applying the unit load method. First you have to apply the unit load at C load, then that sign conventions are tension and elongation you have to take as a negative, and compression you have to take as a positive. Then member AC, BC, P, K, K dash, L, AE minus W by root 2 minus 1 by root 2 minus 1 by root 2 L, AE minus W by root 2 minus 1 by root 2 and 1 by root 2 L into AE. Apply a unit vertical load for vertical deflection. Delta V equals to delta PKL by AE plus equals to WL by 2AE plus WL by 4AE equals to 3WL by 4AE. Calculation of horizontal deflection at C. Apply a unit horizontal load as shown and analyze the truss. Delta V equals to 0 and FCA equals to minus FCB, and the summation of H equals to 0 and summation of CA cos 45 equals to 1 plus FCB cos 45. 2 FCB by root 2 equals to minus 1, FCB equals to minus 1 root 2 negative indicates that tension assumed in FCB is wrong, it is compression. K represents values due to unit horizontal load, and delta H equals to summation of PKL by AE WL by 2AE minus WL by 4AE, that is nothing but a plus WL by 4AE. The positive sign indicates the horizontal deflection assumed towards right sign is correct. So likewise you have to calculate the all member forces using this unit load method. Then change in length can be calculated using the delta sigma epsilon alpha into delta T into L, that is for change in temperature formula. Then that equals to 10 into 10 to the power of minus 6 into 50 into 4000, that you are getting 2 mm. To calculate horizontal deflection at roller support B, apply unit horizontal force, analyze the stress for the given unit horizontal load. Note that no vertical reactions and all the bottom cards have unit force, that is delta H equals to summation of K into delta dash, that is 3 into 1 into 2, that is 6 mm. Support B will more 6 mm towards right. The lack of fit of various members of a truss are shown in figure. Positive indicates shortfall of length, negative indicates excess length. Calculate the vertical and horizontal deflection at C. Calculation of vertical deflection at C, apply unit vertical load at C, calculate the values of K. So likewise you have to calculate the all values, and with this method or with this numerical, I would like to stop this session. Thank you for the listening, and I will continue in the next class. Thank you.